The closest star system to Earth has a binary pair of stars. Is that a good place to search for planets? That's just what Nicole of Oklahoma City, Oklahoma, wanted to ask the universe when she wrote, "Can planets exist in a binary star system?"
Nicole, that's a really cool question. It turns out that a planet in a binary system can orbit either one of the two stars very closely, or it can orbit both of them from very far away, but it can't orbit among them. It can't do a figure eight among them, for example. That trajectory is unstable, and the planet would quickly get ejected.
We may be on the verge of discovering an Earth-sized planet around one of the two stars in the Alpha Centauri system, the Sun's nearest neighbor. It would be a more compelling reason than ever before to explore the exotic science of high-speed space voyages and the time travel that goes with them.
Alpha Centauri is very exciting because it now appears from a variety of different computer simulations that it's quite possible that there could be terrestrial mass planets orbiting both components of the Alpha Centauri binary system.
Alpha Centauri A and B are so distant they look like a single star from Earth. But they're actually a binary pair. A third member of the system is Proxima Centauri, a red dwarf loosely bound to the main pair.
If you're sitting on a planet in the Alpha Centauri A system or the Alpha Centauri B system, Proxima Centauri wouldn't even be visible in your night sky. It's that dim.
Alpha Centauri A and B orbit around each other. At their closest point, they're about 20% farther than the distance from the Sun to Saturn. At their farthest, they're 20% more distant than the Sun is from Neptune. Each has a habitable zone similar to the Sun, where life-bearing planets could exist. And that, after all, is a holy grail in astronomy.
Well, a trip to the nearest stars, for example, Alpha Centauri, that we can do within our lifetimes would be immensely exciting. One of the great goals of science is to find life elsewhere in the universe. What better place to start, other than our solar system, than the nearest star?
But now, space travel becomes time travel, as we set our sights on a mission that can be done under the laws of physics we know now. A mission that can cross more than 4 light years of space in just 45 days. Our quest to unravel the mysteries of time now point us again to Alpha Centauri, the Sun's closest neighbor. It is the most likely first destination for a starship from Earth. A starship whose mission cannot avoid a component of time travel.
We have no idea what kind of technology would actually take us from here to Alpha Centauri and back. Therefore, we might as well be optimistic and say that we just move at 99.99% the speed of light all the way there and then all the way back.
The ship seems surprisingly small for one that has to make such a long trip. How can it hold enough supplies to support a crew for the duration? It can because it is not only a starship, it is also a time machine.
It would take about 8.6 years because Alpha Centauri is 4.3 light years away. But to the people on the ship, it would take less than 2 months. It would take about 45 days because they're traveling close to the speed of light.
The astronauts would also have to overcome the problem of killer acceleration in quickly reaching the speed of light. Otherwise, they'd have to speed up slowly, adding time to the total trip. Alpha Centauri is the go-to destination for Earthbound beings hoping for a toehold in star travel. It's no accident that James Cameron chose it as home to his fictional moon Pandora in the movie Avatar. The reason we would go to Alpha Centauri has to do with today's intensive telescope search for Earth-like planets around Alpha Centauri b, one of 2 stars in the system's main binary pair.
Alpha Centauri b, turns out, is by far the best star in the entire sky for searching for low-mass Earth-like planets. But to carry out that kind of search requires a very dedicated effort. It's not something that you can accomplish in a few nights at a telescope.
It's hard enough to separate the 2 main stars of Alpha Centauri in a space photograph. Trying to see an Earth-sized planet around one of them is, at the moment, impossible. The best shot we have is to find the planet by the wobble method, detecting a star's subtle back and forth motion caused by the tiny gravitational tug any planet would have on it. Like time travel, it seems almost undoable.
The back and forth wobble that we need to detect is incredibly small. I'm here at the Rose Bowl, and if the Rose Bowl were the size of Alpha Centauri, then the amount of wobble that we need to detect is about this much, about 3.3 inches. And we need to detect that from 4.3 million miles away.
Alpha Centauri b is slightly smaller than A, and the planet hunt is concentrated there, mostly because a smaller star will show more wobble and detection will be that much easier. In 3 to 5 years, we should have an answer.
I think that if we were to discover that there's an Earth-mass planet orbiting the very nearest star, then there would be a great deal of excitement to somehow either build a large telescope to try to observe that planet, or perhaps in the far future to design a mission that could actually go there.
With the goal of our time travel quest identified, we can imagine our spacecraft in Earth orbit about to leave on the first mission to Alpha Centauri. The ship's high speed propels it into time machine mode, slowing its clock so its passengers approach Alpha Centauri in 3 to 4 weeks. Seeing things up close, no human has ever seen before. First up, a stellar flare from the red dwarf Proxima Centauri. On the outskirts of the triple system, it is the closest of the 3 to the Sun.
Proxima Centauri is prone to these sudden outbursts that can cause it to brighten up by a factor of 4 or 5 over the course of just a day and then fade back just as quickly. So you might be in for some real fireworks as you pass by Proxima Centauri.
As we come within the triple star system, we might imagine swinging past Alpha Centauri A and using gravity assist to send us in a direction of Alpha Centauri B.
The sister Earth of the ship's destination is the ultimate goal, and the travelers will be anxious to explore it and search for life. Although the trip has taken little more than a few months for the travelers, the high speed will slow down their clocks so much that when they return, nearly a decade will have passed on Earth. The realization of star travel at high speed is a dream for the far future. On an Earth where technology is so advanced and changing so fast, the difference of 8 or 10 years could be dramatic. This kind of time travel may become routine to a new generation of star travelers. Taking mankind on the next giant leap in its epic journey through the universe.